Okay, ninth grade, just a quick science tutorial. Get your books, pause me, but get your books and turn to page 138. Okay, if you look on page 138, about halfway down the left column there, it talks about pure substances. Now, a pure substance is a substance that has the same physical property throughout. I mean, it is the same no matter where you take a sample from the substance, it's always going to be the same. Pure substances can be found uh, with an element. You know, if you have just one element of something, let's say you have pure iron and you have filed it down and you've got a big bowl full of iron filings, that's going to be a pure substance. But also, if you take sugar, which is combined on the molecular level, where you have three different atoms that are hooked together to make one molecule, sugar you're going to find is a pure substance because it's the same in that bowl no matter where you take a sample. It's sugar. And these kind of substances, these pure substances, are called homogeneous substances because they're the same everywhere, from the Greek word homoousios, which means one. Distilled water is an example of a homogeneous substance. Other pure substances are like oxygen, aluminum, gold, carbon dioxide. All these things are pure substances. Now, we know that the world exists not of pure substances most of the time. It consists of things that are all mixed together. And so let's talk a little bit about mixtures. Mixtures are composed of several pure substances that are physically mixed together. They're physically mixed together, but there's no changes that go on the molecular level. They're just simply substances. Your book gives the example of milk and flour, air, gasoline, and seawater. You see, all these substances have different things in them. The air we breathe has mostly nitrogen, but it also has about 20% oxygen, and then it has these other trace elements in it as well. Seawater, it's made up of water, H2O, but it also has salt and other minerals in it, but they're all mixed together. You can take the salt out of the water. You can take the other minerals out of the water. They are physically mixed together, but they aren't combined chemically. A mixture of, let's say, sugar and iron filings. So we've got our bowl of iron filings, we've got a bowl of sugar. And we pour the sugar over into the iron filings. The iron filings are black, the sugar's white. We mix them all up. We can still separate the iron from the sugar. How do we do that? Well, I guess we could get a pair of tweezers and a good pair of glasses and pick out the iron filings one at a time, and we could do that if we had enough time. But what you can do is you can pour water in that bowl with the iron filings and the sugar and let the sugar melt. And then pour the water out, and all that will be left is the iron filings. Or, if you wanted to get the iron filings out, what you could do is take a magnet, really strong magnet, and drag it through that bowl of iron and sugar. The iron filings would stick to the magnet, but the sugar wouldn't. So mixtures that have been physically put together can be physically separated. At the bottom of that page on the right-hand column, it talks about solutions. If the molecules of the substance in a mixture are uniformly mixed, the mixture is called a solution. Now, a solution is going to have two things. It's going to have the solute and it's going to have the solvent. The solute is the solid that's being dissolved. The solvent is the liquid that's going to dissolve the solid. One common solvent is water. Regular old H2O water. Anytime that you have a solution where water is the solvent, it's called an aqueous solid, or an aqueous solution. I'm sorry. An example, seawater. It's dissolved all these different minerals in the water. Another example is honey. Honey is water that has dissolved sugar into it. Carbonated beverage like a Coca-Cola or a caffeine-free Diet Coke, which is my all-time favorite. It's nothing other than water with carbon dioxide put into it. So these are all solutions. Like pure substances, solutions are homogeneous because the physical properties of a solution are uniform throughout. Honey is going to be sugar dissolved in water throughout the whole jar of honey. Seawater is going to be all these minerals dissolved in water throughout the whole glass of seawater. They are solutions, but they're the same throughout, so they're called homogeneous solutions. And you've got a solvent, like water, that dissolves something like minerals to make seawater. All right, that's about 7 minutes. I'll do another tutorial on solutions a little later. You all have a nice